Hello everyone. In this video, I'm going to demonstrate a buffer overflow attack using C labs in a virtual machine environment. So, buffer overflow is a very important concept in cybersecurity and ethical hacking because many real-world vulnerabilities happen due to improper memory handling. In this demo, I'll show what is buffer overflow, why we study it, what is C labs, how to execute level 1 buffer overflow attack practically. What is buffer overflow? A buffer overflow happens when a program stores more data than the memory buffer can hold. Because of this, extra data overrides nearby memory. This can modify the return address and attacker can control program execution. This vulnerability is very dangerous because it can give root or admin access. It allows remote code execution. Many real-world attacks are based on buffer overflow. So learning this concept helps us understand how hacking works, how to write secure programs. What is C labs? C labs is a cybersecurity education platform developed for students. It provides pre-configured vulnerable programs, real attacks practice environment, safe legal learning setup. We use C Ubuntu 20.04 virtual machine for performing attacks safely. What are level 1, level 2, level 3, level 4? C labs provides 4 levels of buffer overflow. Level 1 is for simple buffer overflow, known buffer size. Level 2 is for unknown buffer size. Level 3 is for small buffer, shellcode cannot fit. Level 4 is for strong protection mechanisms. In this video, we demonstrate level 1 completely. So let's start with the practical demonstration, level 1 attack. So I already started the virtual machine. So starting the virtual machine, first we start the C Ubuntu virtual machine using VirtualBox. After login, we open the terminal. In step 2, navigate to lab folder. So here we can observe that the folder is C labs and then category software and then buffer overflow set UID and lab setup. These all are the internal folders inside the C labs folder. So once we install the C labs, we can observe all these folders through the ls command, and then after navigating to the lab folder, we will start working with understanding the vulnerability. So we execute the program .stack hyphen level 1. So we can observe here when I give ./stack L1, it's shown me input size is 401 and segmentation fault. So what is segmentation fault? When we tested with the inputs 5, program works fine. When we tested with the input 100, the program works, but we tested with the input 400, it gives segmentation fault. This shows buffer overflow vulnerability. So, and also we can find the buffer size. We discovered that buffer size is equals to 517 bytes. Here we can observe when I given the command gedit exploit.py. So first let us observe gedit stack.c. So here we can observe that strcpy buffer comma str, and then when we execute this with level 1, we observe the input size is 517. Here we can see this written properly. This means if input exceeds 517, stack memory will overflow. This is the core vulnerability we exploit. So creating exploit.py main attack code. Now we write exploit.py which generates our malicious payload. This script contains shell code, NVOP sled, total size is equals to 517 bytes. So when we run this, so we can see here the shell code. I have replaced with my own shell code, and when I run, I saved this. So when I run this, it should be shown like this. Input size is 517. So when I type this who I am I command, it should show me the seed. So this proves that buffer overflow attack is successful. Now, so what's the conclusion is that in this video we understood buffer overflow, used Seed Labs virtual environment, successfully exploited level 1 buffer overflow, gained shell access. In next levels L2, L3, L4 we'll know about unknown buffer, small buffer and strong protections. We use advanced techniques like memory offset calculation and return address injection. So this practical demonstration clearly shows how dangerous buffer overflow vulnerabilities can be and why secure coding practices are extremely important. Thank you for watching.